Hi friends, welcome to my channel. Let's have a look at another problem 112, pass sum. So actually we come here from solving problem 113, pass sum 2. So in this video, we are going to share two methods for this problem. The first one is actually in parallel to the solution we shared for problem 113. So we are going to use Iterative DFS. So I'm going to write a solution format corresponding to preorder traversal of binary tree. And then we're going to share a second method based on recursion. So first, let's look at the statement of the problem. So given the root of a binary tree and an integer called target sum, so return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. So here are several examples. So in example 3, so the return is false because there's no root to leaf path at all. And in example 2, so there's no root to leaf path which sum to target sum 5, so the return is false. And in example 1, so we found that 5, 4, 11, 2 together they get 32. So there is a such path sum, so the return is true. So with that said, let's also look at the constraints or additional assumption on this problem. First, the number of nodes in the tree is in the range 0 and 5000. So this actually defines the problem size, and also notice that the tree can be a null tree. And secondly, this is the range on node values between -1000 and +1000. So this correspondingly the range of target sum. So with that said, we are ready to look at the method and the simple analysis. So here we are going to share two methods. The method 1 is based on traversal, and the second method is a recursion format. So actually, we come from problem 113 for pass sum 2. So here, the first solution format will correspond to the solution we shared in the video for problem 113, but with some adjustment. So here we store node and root to node pass sum. So because here we just need to check the pass sum against the target sum, right? Not the root to node path list. So after this first solution, we're going to write a recursion solution. So here the consideration is that the tree or binary tree can be defined recursively. So we could think of recursion when proper for tree-related problem. So actually for this problem, this is actually an easy problem. So the two solutions and the codes speak themselves. So we are directly go to the code. So first, I'm going to write a solution based on iterative DFS. So the solution format I'm going to write corresponds to preorder traversal of binary tree. So for this solution, I'm going to first check a special case, if not root. So we're going to return false. So the reason is that there's no root to leaf path at all. So this check actually can be absorbed to the general logic, but let's first do this check. And then we're going to initialize a stack. So the stack actually we're going to have root and root value. So current state, because it contains only root node itself. So the thing we're going to store is node and root to node path sum. So this is the initialization. So next we're going to do the standard while loop. So while stack, then what we are going to do is to check to look at current node and the path from the root and ending at the current node. So that is path sum. So it's stack pop. Then first thing to check is if the node is a leaf node. So if not node left and not node right. So in this case, we're going to do a check for the path sum. So if path sum equals target sum. So in this case, we're going to directly return true. So actually done. Otherwise, so we're going to add the left subtree and the right subtree respectively if they exist. So we're going to check if node right. So here I'm going to first check node right in order to correspond to a pre-order traversal of binary tree. So what we're going to do is stack append, so a tuple which is node right, and the previous value pass sum plus the current node value, node right value. So this is one case, and then we're going to copy this so that we can check the left subtree if exists. So I'm going to change this right to left. That's the main logic for the traversal, and here is actually the problem logic specific to the problem itself. So after we exit this while loop, we're going to return false if nothing has returned. So that's a full solution format for this problem. Let's first do a special case check. Yeah, it passes a special case. Now let's do a generic case. Yeah, it passes the generic case. So with that said, let's do a quick format on recursion. So I'm going to copy this function signature up to this here, and then I'll change this to solution v1, and then I'm going to change this annotation to be recursion. So actually the recursion solution is very short. First, so I'm going to check if not root, so we're going to return false. So this can be regarded as a base case or stop condition. So let's check another case. So if root value equals target sum, and the root is a leaf, so in other words, and not root left and not root right. So in this case, so the add, this first part is check target sum. This is check the leaf condition. So together, so we're going to return true. So otherwise, what we're going to do is that we can check path in starting from root and look at the left subtree and the right subtree. So we're going to make a self call. So for has pass sum, and then we're going to go to root left and to check if there are pass sum that equals target sum minus the root value, right? If starting from the root left and we have a root to left path which has this sum, then if we append the root, so we get a path sum equals the target sum. So then we are going to have another one. So we are going to check this one against the right subtree. So we just need to change this left to right, right? So similar interpretation as the first part. So notice that here the logical relation is all, right? So with that said, I guess that's the second method. So in this case it is false, and in this case is true. So then this is the logical all. And then we can do a special case check first. So target sum is not defined. Let's change this target. So target. So let's check again. Oh yeah, it passes the example. So now let's do a generic case check. Yeah, so it passes all the cases. So here, let's give a quick summary. So in this video, we shared two formats of solution, or actually we practiced two formats of solution. So the first one, actually, if we got it as a graph, it's a DFS traversal. So because we are using a stack as container. So, or if we interpret it as a tree, it corresponds to pre-order traversal of the binary tree. So notice here the relation. So we are looking at the right subtree and then left subtree in order to correspond to a pre-order traversal. In the second solution format, so after we understand the final details by implementing solution 1, so we can write a neat recursion solution, right? So the code here is relatively short compared to the iterative format. So with that said, I guess that's about it for this video. Thank you very much.